With patience, the most tangled cord may be undone. I'm Ray Myers. I'm currently chief architect at All Hands AI, which makes a coding agent called Open Hands. But we have a meetup in town on Monday. If you'd like to hear about that, I'd like to talk about something different today. And you can go to this QR code and find the slides and some other materials you might like to play with if you like. I'll show that again at the end. Now, I study legacy code and ways of working with it. In order to know that those ways work, I test them on the most extreme examples I can find, some of the worst code I can find. So let's look at today's tangled cord. Beautiful, utterly incomprehensible. I love stuff like this. Now, this is by a fellow named Andy Sloan, and it was a winner of the 2006 International Obfuscated C Code Contest, the IOCCC. There are contests apparently for making unreadable code, and I have a lot of fun with their winners. So what does that do, right? Obviously, we cannot tell by looking at it what it does. So let's run it. So we compile it, we run it. It's got this ASCII art. There's like this spinning 3D donut in the middle. You might be able to see better the other monitors. There's a checkerboard waving back and forth. It'll come around again. There's a banner at the top that says IOCCC 2006, the name of the contest. Just that blob of code does all of that. How does it work? How could this possibly work? And more importantly for us, how could we know? What if you went to work on Monday and the code in the repository looked like this and you had to maintain it? And if you didn't, the payment system would break or something, right? Like, what would we do? The tools that would help us even in this situation, those are tools I trust. That's the exercise we're doing here. Now, as I happened to be playing with that one, it was March 2023. You may remember that month well. GPT-4 was released. We had seen ChatGPT before that, but when GPT-4 came out, things got a little weird. It was much more lucid than we had seen before, and the code examples were very impressive. We started wondering, with any little thing we're doing, can ChatGPT just do this for me? And so we can paste all that into ChatGPT. It's small enough to fit in a prompt. Hey, ChatGPT, can you improve this code? And it will report that, yes, certainly I can. Certainly I can. Here's an improved version of the code, blah, blah, blah. And this is the result. Now, you could paste that and compile it. You may know what's going to happen here. Not only is this not an improved version of the code I gave it, it's not even code. It doesn't compile. It is a code-like substance that has come out of this. But to give it credit, there are some insights being expressed in terms of things we might like to do with the code that are reasonable. We would just need to execute them in some other way. Now, when you point out the limitations of a particular technology, as you should do with all technology, in this space, for some reason, people have this refrain. They say, the models will get better. You may have heard it. So real quick, I'm going to recap the last 2 years of the models getting better since some time has passed now. GPT-4 breaks the code. Claude Opus breaks the code. GPT-4o breaks the code. Claude 3.5 Sonnet breaks the code. Now, the models were getting better. That is true. 3.5 Sonnet is amazing. I don't want to downplay that. But on not only pathological examples like this, but even moderately challenging legacy code, it will break it if you let it edit it. So then we thought maybe we need reasoning models so they won't make such obvious errors. So now O1 could now break the code. And finally, a few weeks ago, you may have heard DeepSeek R1 came out with a breakthrough in reinforcement learning in the training process that was so shocking that it caused a $1 trillion correction in the stock exchange. And I am now able to report that finally it also breaks the code. So I know you may have some code that it doesn't break. That's fine. Or you may have some code you don't mind if it breaks, and that's fine. But for some of us, our reality is that the new magic breaks our code. What if we were to just accept that? What does that mean? Well, we will need the old magic as well. We will maybe need them both together. So what is the old magic? Well, one thing we do in the old magic is we have tests. So let's put some tests around this code. And it's actually relatively easy to test. All it does is spit out a bunch of output, so we could capture that to a file, take the first 5,000 lines of output from this file, and that happens to be more than the full cycle of the rotation. If we modify the code, run it again, and get an identical log file out of it, we can be pretty confident we haven't broken anything. Excellent. So we have our safety net. Let's look at this code a little closer. So to get this running well on a modern system, I did a couple things out the gate. So I added the argument types to the main function and others that had been inferred. For instance, in C, the arguments to main are always int and char star star. And I added that little, you can see it on the monitors, a sleep function at the very end in an outer loop I had found, which adds enough delay so that the animation plays on modern computers and you were able to see it. Now, the test pass, real quickly, I'm going to point out actually also that at the top, I can go back. There's a notation at the top here that has an @ sign before the commit message. And that @ sign indicates that I edited the code with my hands. That's significant here because the last time I'm going to do that, because my dirty little hands are too unsafe for me to be editing this code. That's the level of paranoia we're exercising here. We are going to avoid manual edits. So our next edit, fortunately, is automated, and it is to run the formatter. You may normally trust the formatter, which is fine. On code this treacherous, sometimes the formatter breaks it. Formatters are not perfect. So in order to make sure the formatter has done its job, I'm going to compile it, run the formatter, compile it again, and diff the binaries themselves. And they are identical. So I believe that I can save this formatted code. So this is what it looks like now. It doesn't look like code I can understand, but it does at least look like code and not ASCII art. This is progress. So let's look at the first function here. I'm going to ask ChatGPT for help again. I'm still having trouble reading it, but I'm going to ask it differently now. I'm going to ask it, instead of giving me the new code, give me some things you would like to do to this. I will figure out how to get them done, right? And it suggests renaming this from P to render glyph. Might be a good idea. I'm not really sure at this point. It makes several other suggestions. So I'm going to implement them again, not with my hands, but with the safest tool I know right now as I was doing this, the JetBrains IDE, to do safe renames and other refactoring operations. So we'll carry out the rename that way. And the test pass, because when you do automated syntax transforms, they almost always pass. Tests are almost redundant at that point. Applying several others. And adding loop braces using the linter this time. Use the IDE to convert a ternary to an if, etc. Not going to go run through every single change, but it's all in the repo if you want to look. It's renamed. This is a helpful change, actually, very helpful. Renaming B to frame buffer, which is this global here. That's going to help a lot in understanding all the rest of the code everywhere that's used, because that frame buffer is where the characters are assigned before they're displayed to the screen. So this is what we're ultimately producing to make that animation. Then we extract a constant, which indicates the width of the terminal, several other constants. The prompt I was using at the time, I later developed into a GPT on the GPT store, which used to be a thing, if you remember, called Refactor GPT. But I think this audience is probably somewhat experienced at LLM prompting. So you can look it up in the slides if you like, but I'm not going to cover that in depth right now. The point is, I'm asking it not for new code, but saying specifically, don't list new code. Just give me suggestions of the kind that I'm able to execute in a safe tool. So this is basically like LLM tool use, if you've done that. So we have some more suggestions from ChatGPT over on the main method, and I'm going to apply some of them. An example of how we're bootstrapping from very little insight, but just getting what we can out of it, is it's saying, let's make A angle A. The reason we could know that it's angle A is because it's being passed to sine and cosine. And the only thing you can pass to those is angles, the only thing that makes any sense. So I'll take it. I may not know what A and B are, but they are angles. All right. It's also suggested, and I took at the time, a suggestion of renaming the function E to render donut. Now, that turns out to be a mistake. You might call it an LLM hallucination or just a bad suggestion or whatever. But what's nice here is that it's not a suggestion that breaks anything. I hadn't really allowed the opportunity for bad LLM output to break anything. It's just going to give me a confusing name for a while until I realize the problem. The code continued to work. Another thing here is that the initializers are all on one line because this person codes like a lunatic on purpose. And so using the linter, I can spread those out into multiple lines, applying several other suggestions. And moving on. So I've noticed like a blob of stuff here with that outer for loop. It's for some reason not highlighting on the big screen, but I've noticed a blob of something that in the outer for loop that looks like it could be extracted. I'm not entirely sure what it does. It does a lot of calculations and then it updates the frame buffer. So I'm just going to call it update frame buffer, and we'll figure out more about what it does later, perhaps. So more or less at this point, I realized that what I had called render donut before is actually should be render banner. So that gets renamed. And this remaining bit at the top with that for loop must be rendering the checkerboard, sort of by process of elimination. And if you look, there's a string, if you can see it in the middle, that has a dot and a pound sign, meaning that's the only two things that block of code sets in the frame buffer. And if you look at the animation, the checkerboard is the part that only has dots and hashtags, so that must be render checkerboard. All right, now this main method is actually starting to look pretty respectable. I can kind of see the phases of operation. The part that is not obvious to me yet is these control codes that are being printed out. So we could look that up, but ChatGPT is actually perfectly capable of giving us enough context to know the first one should be clear screen, and the second one is move cursor to home. So we'll add comments there. So here we have the final code, at least where I ended up stopping that particular session. There's a bunch of constants at the top, some nasty globals there that if you look at the data flow is not actually that hard to get rid of and make non-globals. Then there's 5 helper functions that have been extracted. This is render donut, which is maybe the most interesting part of the program. It is doing some very complex trigonometry to draw this 3-dimensional donut. And at the bottom, there's that magic string, which has sort of ascending levels of shading to paint the donut different ways. And I realize this is complex code, but within the space of you're drawing a 3-dimensional object and then doing like primitive ray tracing on it, it is now fairly straightforward. So it's more doing a complex thing than obfuscated intentionally, at least. And then we have render checkerboards doing some much simpler trigonometry, just assigned to make it waver back and forth, and then some math to draw this sort of projected square and draw it with either dot or hashtag, depending on whether it's like the white or black parts of the checkerboard. There is render banner here, which this one actually is still kind of a mystery at this point. Like, it's got 2 helper functions, which they'll suggested to name code to index and render glyph, which kind of seem like reasonable names, but we don't really understand in context what's going on here. There's some magic strings, and then these 2 helper functions. So, and this giant magic string here is a total mystery. So call that one mostly lost. And then after we put whatever we do in the frame buffer, this is print frame buffer that actually just renders a frame of the animation. and the main function that drives it. So I'm going to say, looking at this, not too shabby. This is not now great code. It's not now even clean code, but I can work with it now. I've made multiple changes, added features to it based on this, where before it was just completely incomprehensible. So not bad for one session, right? And in that process, humans almost never directly touched the code. Automation made most of the changes, and LLMs never directly edited code, only made suggestions. And nothing broke. There was rarely even a test failure, if there ever was one. So what did we use to do this? Well, it is true to say we used AI. That is something that happened, right? But a lot was going on. Different components kind of used to their strength, right? You have a human expert in legacy code. You have a language model, GPT-4. You have algorithms in the form of the refactoring support of the JetBrains IDE and the Clang linter. And then you have development practices, which we're kind of using lightweight versions of here, which are very powerful in practice, like naming as a process by Arlo Belshi. Test-driven development, or actually a stricter version of it called test commit revert, where we would wipe out a change if the test ever failed, by Kent Beck. And the forms of the tests we were using were approval testing, which is popularized by Emily Bache and Llewellyn Falco. These are all very useful people to get to know if you have such issues in your life with legacy code. So the main cycle, not the only thing that was done, but the main cycle that we followed here is AI makes a suggestion. I decide if we want to do it. I use the IDE to perform a refactor and run tests and do an incremental commit. Now that worked reasonably well just with me orchestrating that process manually, but it can be heavily streamlined. If we were just to totally streamline it and make it a headless loop, then it would look something like this. And this is another entry to the same contest. We have LLM generated suggestions being created and applied, test run, commits on the left is the git hash of the commits that result. And then you just kind of watch the code reshape itself in real time. Now, you probably want to slow it down a bit from that and give you some feedback of like which suggestions are we gonna take or leave. But you know, this can get very smooth. And lest we be limited to only doing refactoring operations, because even though those do get very powerful, there's obviously things we would want to do other than that. There's also this whole branch of computer science called formal methods, which I ended up spending most of last year learning. And on my YouTube channel, Craft versus Cruft, that generated about 12 different videos. Maybe my next talk will focus more heavily on that. But after that year, what I was left wondering is, why are we putting so much on whether or not we're able to get LLMs to exhibit reasoning capabilities when automated theorem provers already exist? I think they're being almost entirely left out of the conversation. How many in here have used a proof assistant ever? Awesome. Awesome. That guy's cool. And if you use Prolog, half a point. So anyway, we're going to need a lot of tricks. We'll need a lot of different tools here because new code is easy. It's easy for AI and it's easy for people. New code was not the hard problem this whole time. Old code is hard. But here's the problem. New code becomes old code. You may have noticed this. So just focusing on what works on new code, it's not a long-term strategy. It does not work. And this won't be easy. We should not expect it to be. Some problems an AI is not going to just come on along and solve for us. Like, for instance, how does that banner code work? The AI couldn't help us figure that out. And somehow that magic string becomes that banner. The answer's got to be in there somewhere. So anyway, back in March 2023, I posted that initial session, and I actually ended up inadvertently summoning the original author, Andy Sloan. He commented on it and said many interesting things, including, I am amused and somewhat satisfied that nobody's figured out how the logo is encoded in 15 years, and now ChatGPT can't either. Well, We couldn't really let that slide now, could we? So 6 hours later, that I will never see again, I did figure out how the banner was done. And you might, remember some of these terms from computer science class. If not, that's fine. But there is a run length encoding done that produces a result that's encoded with 2 different Huffman encodings. That produces a long binary string, which is divided into 6-bit chunks and then reversed for no good reason. And those chunks are converted into a base 64 ASCII encoding using the characters between greater than sign and tilde. And that is how this becomes this magic string. I'll let the author know. I think this is what you're doing. He confirmed. Indeed, I had figured out, and I was the first person to do so. And I will prove to you now that I do have the exact encoding process, because I can replace that magic string now with another magic string. We can run it again and put a different message in it. So instead of IOCCC, it now says AI native dev. And Patrick, that is a great name, but perhaps the better name for this one would have been Dev Native AI. Thank you, New York.